In this video, we're going to talk about factoring with common terms. Now, factoring is, well, first let's determine what a factor is. A factor is quite simply a number or quantity that, when multiplied with another number or quantity, produces a given number or expression. So, in other words, if I could turn this, if I could find a factor of these things, I could make this into something times something would give me this whole expression, or something times another something gives me this whole expression. So what I'm trying to do is I'm trying to figure out what is common between these two things, or what is common between these two pieces that would turn them into two or more factors. So let's start with this one. This one says 2x plus 8. Now you might even see, these are both even, so a common factor would be 2. Excuse me. A common factor would be 2. So if I factored out a 2, I'm thinking 2 times something gives me 2x, and that's going to be x. And 2 times something gives me positive 8, that's going to be 4. So now I've changed this into two factors because I've got 2, which is a number, times a quantity, x plus 4, that when multiplied gives me another number or quantity, or a given expression even. So 2 times x gives me 2x, 2 times 4 gives me 8. So here, this thing is now factored. Now this one over here on the left, this might be a little bit more tricky, but it might not at this point for you. What we're looking for is we're looking for the biggest factor that we can pull out of these two terms to create a factored expression. Now, if you're looking at this and you don't quite know what are all the factors for these things, you might see, I've got 3 in here, or maybe you're looking and you see that there's some x's in here, but you're not quite sure which one to pull out. The idea is think about all the things that are required to multiply together to get this. So 3 times x squared would give me 3x squared, and x squared is actually made up of x times x. So the factors of 3x squared is 3 times x times x. Similarly, for 6x, I've got 6 times x. Well, 6 can also be factored. Yes, you can say 1 and 6, but one that might make a little bit more sense in this fashion is 2 times 3. So 2 times 3 times x gives me 6x. So if I'm factoring something, I want to see what is common between all of these. So I can see that 3 and x is included in both of these. So that 3x would be what's factored out, and what remains is going to be x, and then we've got plus 2. So that way we can kind of see where this comes from. The 3x, the x, which is what remains here, and the 2, what remains here. So 3x plus 2. And again, if I take 3x times x, I end up with 3x squared. If I take 3x plus 2, I get 6x. So you might be looking at this stuff and you might be saying, yeah, I get all of that. But then as you start getting into maybe you're factoring quadratics at this point and you have something that looks like this. This is a quadratic in standard form, and maybe you're asked to factor it. So you go through the whole splitting the middle term process, and you come up with this piece right here. At one point, you might have been allowed to keep this and say this is 2 factors. But the problem is this is not fully factored. And when we want something, when you factor an expression or a quadratic, you want to fully factor it, which means, as we saw right here or over here, we know that this thing can actually be written as 2 times x plus 4 times x plus 1. So this piece here is now fully factored, whereas this piece is not fully factored. So as you are factoring, make sure that you are fully factoring, because when you are asked to do that, it is expected that you come up with 2 or more factors. So 2 times this, or 2 times this, or 3x times this. Now, what if we were to look at something that looks like these two expressions. Now, here you may notice that this can be factored if we split the middle term. Let's just say, hey, we've got a 1 out here, so we take 1 times 6. 1 times 6 is 6. Sorry, is equal to 6. Let's put that there. And we want to find the factors of 6 that add up to 7. So I'm going to look at 1 times 6, and I'm going to look at 2 times 3. And if I add these up, that's 7. If I add those, that's going to be 5. So this is the factors that I want to split that middle term. So running through this real fast, we get x squared plus 1x plus 6x plus 6. And if I factor that, if I look for my common terms, here, I see that x is one of my common terms. I'm left with x plus 1 on the inside. And I'm looking to see what's common here. I see that it's a positive 6, and I'm left with x plus 1 on the inside, which leaves me ultimately with x plus 6 and x plus 1. If you didn't quite follow all of that, go back and check the splitting the middle term or factoring quadratics video. Now over here, you might think, oh gosh, now I've got to multiply 2 and 12, and I'm going to come up with factors of 24 that add up to 14. Maybe you can do that easily, maybe you can't, but there's a lot more factors of 24 than there are of 6. But what you also might notice, like, so we could go through this whole process and we could factor out like we did over here with 24. Or if you notice, all of these things are divisible by 2. They all have factors of 2. So at the very beginning, I could I could factor out that 2, and what I'm left with is x squared plus 7x plus 6, because 2 times x squared is 2x squared, 2 times 7x is 14x, and 2 times 6 is 12. So now at this point, look at that. Now I've got a nice easier set, or a nice easier trinomial to factor, and I actually already did it over here. So we know that this thing comes out to x plus 6 and x plus 1. So it's nice and easy to factor this. This is going to be much easier. We can do that in our head, where this might be a little bit more difficult. So if you see that you've got a common term between all three of your trinomials, or all three of your quadratics, you can factor out that common piece first, and what you're left with, then factor that. And notice that the 2 comes along. The 2 doesn't disappear. It's still part of that, because if I wanted to go back up to this original piece, this original expression, I would have to multiply all three of these things together. So don't think of it as the 2 going away. You're just factoring the 2 out, and then you're working with this part inside here. So hope that helps, and I'll talk to you in the next video.